Hello friends, my name is Shamli and I am welcoming you to in my new video. In this video, we will discuss about speed and velocity. Let us start with the good thought that be the change that you wish to see in the world. Welcome to Explore Physics. In this video, we are going to discuss about the speed, velocity, uniform speed and the uniform velocity, along with that non-uniform speed and non-uniform velocity, average speed, average velocity means what. After that also we will discuss about instantaneous speed and instantaneous velocity. All these things are important whenever we will learn about the kinematics chapter. In this kinematics series, this is the most important topic where many of the students will get confused. To avoid their confusion, here all the things I have taken at the same time so that we can differentiate among all the cases. Okay, let us see the next one. First of all, we will see the definition of the speed. 1. The distance traveled by the body in a unit time is called as speed. Here, speed formula we can formula we can give it as a v, which is equals to distance by time, that is s by t. V is equals to s by t is the formula for the speed. It is scalar quantity, therefore direction doesn't matter at all. Only magnitude matters. Its CGS unit as distance measured in terms of in CGS centimeter divided by second, therefore centimeter per second. And in case of SI unit, distance measured in terms of meter and time measured in terms of second, therefore meter per second. Dimensional formula: meter as mass term not there, therefore m naught. Meter one term is there for L1 and t power minus 1 as one term of time is there, but in the case of denominator, that's why. Okay, let us see the next one. Now we will discuss about the uniform speed. What do you mean by uniform speed? Equal distance covered in equal interval of time is called as uniform speed. For example, suppose here I have taken one bike, right? The person is going from initially from one position to another position. Here direction doesn't matter at all, we can consider anything because this is the speed in which only magnitude matters, we have said already, right? So here distance this object is covering, this person is covering something distance. How much a distance it is covering? It is covering equal distance in equal interval of time. It means in every second, suppose it is covering 5 meter distance. So what we can say? It is moving with the uniform speed that is equals to 5 meter per second. Here we can see here in 1 second 5 meter, in next 1 second 5 meter, another second 5 meter. So in every case, if object is performing 5 meter distance, so we can say object is moving with uniform speed of 5 meter per second. Opposite to this, if we will discuss about the non-uniform speed, what will happen? Here, unequal distance will be travelled by the equal intervals of time. Here see, I have taken 1 second example only. 1 second, in every second, in first second, object is moving with 5 meters. In another second, different object is moving with a different speed, that is 8 meters, right? In another 1 second it has covered 10 meter distance. So here in every step what is happening, 4 6 7, in every step distance is getting changed though the times are constant, right? So here in 1 second 5 meter means object is moving with 5 meter per second. 1 second in 8 meter in 1 second means 8 meter per second. 10 meters in 1 second means 10 meter per second. 4 meters in 1 second means 4 meter per second. Just like that 6 meter per second and 7 meter per second. Here variable speeds are there. Therefore we can call it as a non-uniform speed. Unequal distance covered in equal interval of time. This is the one case. What happened if I will take 5 meter constant here? It means distance constant I am considering here. Suppose all are 5 meters only, but timings are getting changed. Instead of 1 second, something is 2 seconds, somewhat is 4 seconds, somewhat is 10 seconds. So that is also unequal time interval. It means equal distance covered in unequal interval of time, then also that speed or that variable speed is called as what? Non-uniform speed, or we can call it as a variable speed. Understood? Example, if I want to give, what example I can give? Motion of a freely falling body. For example, I have dropped one object from up to down. Here, as acceleration due to gravity working on that object, definitely it will move downwards only, but definitely it will move with variable speed, right? As downward perfect motion will be there, that will comes under the velocity. Here, as we are talking about the speed only, so no need to talk about the direction. In the same case, see here, I have written one another example, that motion of a body thrown vertically upward. If we have thrown object vertically upward also, same acceleration due to gravity as working downward continuously. So what will happen? Non-uniform speed will get developed. Means in every case, distance covered by the object will be different. Understood? This is all about the non-uniform speed. Once we understand the uniform and non-uniform speed, it is very easy to understand the average speed. Now, what is meant by average speed? Here, average speed definition I have written: total distance traveled in total time interval. For example, in previous case I have considered this one: 5 meter, 8 meter, 10 meter. Total distance I need to add. Suppose just like here, this is S1, this is S2, this is S3, so on. Suppose this is 3, 4, 5, 6, this is S6. We need to add a total distance. In 1 second, this is T1, T2, T3, just like T6. So here what will happen? In average speed condition, total distance travelled by the object, that is S1 to S6 all, okay, divided by T1 plus T2 plus T3 till T6, all we need to add. Here n number I have given. Here in the previous case we have seen the 6 cases, that's why I have written 6, right? So average speed will be equal to total distance travelled by the object or the person divided by total time taken. Got it? This is also denoted by the letter delta S by delta T, that is total distance traveled, where limit tends to t tends to 0, which is not equal to 0, but it is going to be 0. This is also called as average speed. Same like that, if we will consider, we are talking about the specific direction, in that one direction only or specific direction only. So in that case, that average speed will turns to the average velocity. One by one we are going to see that also, but here in the comparison, if you will see, it will be easy to remember. That's why I have explained here about the velocity also. What is this velocity and the average velocity, all we will see again in the next slides. See, the next one is instantaneous speed. What do you mean by instantaneous speed? Here, whatever speed is getting developed at that particular instant of time. For example, object is moving in 1 second, 5 meter distance, right? So this 5 meter in that particular second, so speed developed will be equal to 5 meter per second, right? So that 5 meter per second is the instantaneous speed at that particular time, right? In this case, in our bike, if we have seen this type of figure. This is nothing but what? Speedometer. It means at every instant it will show us now at what speed object is moving, how much distance object is moving, right? So here in that particular instant, so the speed of particle at that particular instant is called as instantaneous speed. If we are talking about the velocity at that particular instant means at a perfect direction also will matters, at a perfect direction and at the perfect magnitude, what is the change in the velocity, that is called as what? Instantaneous velocity. Here instantaneous speed we are discussing. In our bike, in our vehicles, whatever we are seeing this type of figure, that is nothing but what? Speedometer, and it will measure instantaneous speed. I hope you understood. The next one is velocity. See here, as velocity we have seen about the scalar and the vector quantity. In that I have given you the example about the vector quantity, right? Vector quantity means what? In which magnitude as well as direction matters. Direction matters means here magnitude, if I will change the value of the magnitude, direction of the object if I am not changing, then also velocity value will get changed. If I am not changing magnitude, if I am only changing the direction, then also velocity value will get changed. If I am changing both magnitude as well as direction, then also we can change the value of velocity, right? What is this velocity? The displacement traveled by the object, or we can say the displacement of the body in the unit time is called as what? Velocity. See here, already I wrote velocity is nothing but what? Vector quantity. As displacement is vector quantity, therefore velocity also becomes the vector quantity, right? CGS unit, right? CGS unit is what? Velocity also. Displacement means s bar by t only. So displacement measured in terms of centimeter divided by second, denoted by v bar here. Okay, SI unit whenever we are talking, it is measured in terms of meter divided by second. So SI unit is meter per second. Dimensional formula of speed and velocity both are again same, m naught L1 t power minus 1. Let us move towards the uniform velocity. As we have seen, every second 5 meter distance if object is covering, in 1 second 5 meter, here also in 1 second 5 meter, again in 1 second 5 meter. So whatever this distance covering by the object in a equal interval of time, equal displacement, that is nothing but what? Uniform velocity, and in the particular in a one direction only. Understood? So this is all about the uniform velocity. The same case, but here in non-uniform velocity, what we can say? Equal distance traveled in unequal interval of time, or as I have explained in the non-uniform speed, unequal displacement traveled in equal interval of time, that also we can say, right? Again, the velocity value, if I want to change, variation of velocity will be done by changing the value of magnitude, or changing the value of direction, or changing both, that is magnitude as well as direction. We can change the value of velocity, right? Variation we can create in the velocity. Next one is average velocity. Again, the average velocity is same like the average speed, but in the particular direction, that is total displacement of the object by the total time. Total displacement, how much object has been covered? Suppose 50 meter covered, in how much a time covered? 5 seconds, this much time covered. So 5 ones are 5, 5 twos are 10. So object is moving with 10 meter per second with the average speed. But average speed compulsory should not be equal to instantaneous velocity, right? At that particular instant, different velocity may get created. Therefore average velocity sometimes may be equal to the instantaneous velocity, but it is not compulsion that it should be equal only. Okay, here instantaneous velocity delta s by delta t I have written, that is small change in displacement by small change in time. Also we can say x2 minus x1 by t2 minus t1, right? This is also one of the example of instantaneous velocity only. Formula we can say instead of example. X2 minus x1 means what? At that particular last interval, final velocity, final displacement minus initial displacement divided by final time minus the initial time, like this. Then also we will get the instantaneous velocity. Next one is graphs of the motion. These graphs are very important. Whenever we are discussing about the motion chapter, graph will play very important role. Let us see the graphs one by one. Here in this case, whenever we will talk as object is not moving with respect to time, this is nothing but what? Position of the object. And when I am saying object is not moving with respect to time, then the ratio, the graph will come as a straight line. Straight line means what? Slope of that graph is 0. Slope is 0 means velocity also equals to 0 in that case, right? In the next one, you just see whenever equal amount, suppose object equal time interval is there in equal distance covered in equal interval of time, then the whatever graph will form, that is the straight line starting from the 0, or if it will be not starting from the 0, then also uniform may come, so it will come from the upper side, right? Don't get confused here, both are the different graphs. This is also uniform motion graph only, this is also uniform motion graph only. Here in this case we can say slope is positive, slope is positive. What happened if slope is negative? As we have seen, velocity is nothing but what? Vector concept. Well, vector concept means velocity may be positive, negative or 0. Here negative means slope may be negative, right? As slope negative means velocity is still constant but opposite in direction coming. Therefore, graph is coming downwards in direction as shown here in this third figure, right? In this figure like this. Now, if object is not moving equal distance in equal interval of time, or we can say unequal distance it is covering in equal interval of time, means what? Non-uniform speed, non-uniform velocity if object is performing. Here what happened, whatever time is there, whatever position is there, that is variable for each other, means that is not fixed at a time. Therefore the slope will come as a curve path, and this is called as what? Non-uniform motion graph. All graphs are very important. One thing we need to remember, when object will comes in the state of rest, this is the position time graph of that particular situation. Here whenever objects are in the motion, three cases will get developed. In this first case is what? Object is moving with positive slope, object is moving with a negative slope, and here object is moving with non-uniform speed or non-uniform velocity. Understood? Graphs of the motion are very important. Next one we will see about the applications, where the applications will work. Whenever, first application is whenever two equal distances, half distances have been covered in different with the different speed, with speed v1 and with the speed v2, then the average speed of that particular situation or that particular body, we can call it as a 2v1 v2 by v1 plus v2. Got it? In this case, one more application you just remember, this is for what? If equal distance is covered with the different speed, that is v1 and v2, right? What happened if different timings are there, means times are constant, time is constant, here distance is constant, velocities are different, right? Now timings are constant, velocities are different, so it will be v1 plus v2 by 2, v1 plus v2 by 2. For more velocities we need to add going on add that terms. Okay, second situation is if body is traveling between the two positions, right? The total distance is divided into n equal part in that case, and so that the average velocity formula I can write n by average speed is equals to 1 by v1 plus 1 by v2 plus 1 by v3 plus so on till 1 by vn, right? This is also the application of the average speed. Now the next one is third and the last application in this case, as we have seen the four, I have not written here one, that is time constant. We have not written, if time is equals to constant, average speed formula is v1 plus v2 by 2, right? Here see, this is the next application. The body traveling between the 2 points travels with the speed v1 in time t1 and travels with the speed v2 in time t2. Then the average speed formula will be v1 into t1 plus v2 into t2 divided by total time taken. See beta, already what we are learning here, in this case we have already learned average speed is nothing but what? Total distance by total time, or total displacement by total time if we will talk about the velocity. Total distance by total time is what? Distance s is equals to v by t. So I want here distance is equals to v by t, but here v1 into t1 given, so it means what? v1 into t1 plus v2 into t2 divided by, sorry, here v is equals to s by t will come, so v into t will come. So displacement, here see, we know the formula, v is equals to s by t. v1 into t1 is nothing but what? Displacement. v2 into t2 displacement again, and total time taken. So total distance or total displacement by total time here we have discussed, right? I hope you understood these 2 points, speed and velocity, very important concept. And here I have tried to solve all the confusion parts. So as confusion you will not create in this case, because all the things I have taken at a single point, right? So I hope you understood. Thank you so much. Please like, share and subscribe. Thank you.